Hi guys, it's Virginia. I am going to do a quick example on using the law of sines to solve angle side type problems. And you would find problems like these if you're in Math 1151. They'd be in homework 4.1 or something. That's section 4.1 in the pre-calculus textbook. Or if you're in 1269, they would be in homework 5 probably. So here's the example, and I'm given side length, or angle A, angle B, and side length A. So the first step, I'm going to use the sum of the angles in a triangle to calculate angle C, because that's just the easiest thing to do to start with. So I got 71 for angle C. And now I can choose, because when I have an angle and I know it's opposite side length, and I either know another side length or another angle, I can use law of sines at that point, because then I'll only be left with one unknown. So I'm going to go ahead and just pick angle side length B, and I'm going to first find the formula. So what I like to do is, after you've watched the video, if you want to refresh your memory on the examples or find formulas, I like to go to the slideshow links down at the bottom. And so you can find, actually this isn't the best view. The best view is actually kind of seeing more at a glance what's going on. So there's more examples here too as well, of course. So I'm gonna use this equation to solve for side length B. So here is my little demo calculations. So setting up the equation, rearrange to solve for B. So I'm just going to multiply both sides by B, and then I'm going to multiply both sides by A from here, and then divide both sides by sine of A, and just do a little bit of algebraic manipulation to get B by itself. And then I can plug in all of my known values. Now at this point, I like to use Desmos Scientific Calculator. So if you just go Google Desmos Scientific, it'll pop right up. Or if you don't have a graphing calculator or you just don't feel like getting it out, it's really nice. So I go 15 sine of, what was it? 75 over sine of 34. Sine of 34. And just make sure you're in degrees, because if you're reporting your angles in degrees, and you get all of this. So at this point, you're getting an approximate value. So I like to just remind myself by switching up this equal sign for an approximate symbol, because this isn't exactly this. And so once you start working in the world of decimal approximations, you really want to pay attention to what is the problem asking for. So 2 things to remember once you're in the approximate realm. First, read the problem to know how many decimal places are required. And then if you're using this answer, like what we got for B here, in your further calculations, you want to keep as many decimal places as possible when you use it again in calculations, just so that your errors don't accumulate or your approximate values don't become more and more approximate. In this case, we don't need to use B again, so we're not going to worry about that, but we do need to read the problem. So that says up here, round lengths to the nearest hundredth. So of whatever the unit the lengths are in. So we're going to do 25.91 for B. Okay. Now, the only thing left to solve for is C. And since it's basically the same configuration as we had with B, we know what angle C is. And we have angle A and side length A. We can just use exactly the same process that we used to solve for B. So we're going to set up the equation. It's the same rearrangement, algebraic switch around. So here, I'm not going to plug this into Desmos. I already showed you guys that. So that's pretty easy to do. And this is what Desmos will report to you. Now just remember, this is approximate. So we know we need to go to the hundredths place. So this is a 2, so we're just going to do 25.36. And we're done. Now, another thing that I like to do here before you submit it is these values are really easy to mix up. If you have multiple answer blanks and you're doing some calculations and then you're pulling them from your sheet of paper over into the tool, it's really easy to just copy down the wrong number. So a great thing to do is when you're looking at triangles to make sure that the numbers make sense with the angle sizes. So 75 is really close to 71, but it's larger than 71. So the longer side length should be opposite the larger angle. So 25.91 is larger than 25.36. They're really, really close, but this one's a little bit bigger. And so that everything checks out. And then, of course, the smallest angle has the smallest side opposite it. So we should be good. Let's go ahead and check our work, and everything matches up. Another thing that I would suggest is if you are getting partial credit and feedback gets turned off for whatever reason and you're not understanding why, check the solution to see how many decimal places are reported there, because that's probably going to be a good clue what could be going wrong. So I hope that helps, and thank you guys for listening.